Okay, so our second one. We're going to prove that sec A equals tan A sin A plus cos A. Now this one is actually, believe it or not, looks fairly straightforward, I think. Maybe, maybe not. There's no squares or anything, so that sort of helps. So which side should we start with? The bigger side? So the right-hand side. So yeah, this one, if we've got a larger side and a smaller side, sometimes it's just a matter of a simplification question. Yes?
What's meant to be between 10 and 9?
There's nothing there, so that's a times. So tan A multiplied by sin A plus cos A. Okay, so we're going to start with the right-hand side. Right-hand side equals tan A sin A, tan A sin A plus cos A. So, okay, so what could we do? How could we start this one? We've got a tan, a sin and a cos. And remember, we're looking for a sec. So what is a sec? It's worth pointing out that. 1 on cos theta. Guys at the back. 1 on cos theta. So we really would like to reduce this right-hand side down to something with just a cos theta. Okay? Because once we get to 1 on cos theta, we have sec. So a tan. Tan sort of sticks out like a sore thumb there. Can we do something with that tan? Tan is sin on cos. So we have sin on cos, sin A on cos A multiplied by sin A plus cos A. Now we have, so that's sin A squared, sin squared A over cos A plus cos A. Okay, looking here guys, so now we do have this sort of sin A thing. Now, yeah. So let's think about this in terms of, I see where we're going. Now, what do we have here? We've got a fraction, and we've got a cos A here. So maybe it might be helpful. I'm giving you a big hint here, but we're going to make this into a fraction. Now, and this is the other sort of, so on the last proof we did, we had an expansion pattern that we had to see. Okay? In this case, we have a couple of fractions here. Now, we're going to end up with a fraction, but only one fraction. So we have two fractions here. What can we do to make these, to be able to combine these two fractions? They have to have the same what? Denominator. Yeah, same thing. I know what you mean. So we have to have the same denominator here. So what's the easiest way of doing that? What can we turn this denominator into? Multiply it by cos A. But if we multiply by cos A on the bottom, we have to do the same on the top. Okay, so I'm going to multiply by that on the top and the bottom, and I end up with, so sin squared A over here on cos A, plus cos A plus cos A, is cos A squared, cos squared A on cos A, which I can say, well, that's sin squared A plus cos squared A on cos A. Oops. What can I do with that? Top equals 1. So now I've got this sin squared A plus cos squared A. That part goes to 1. So I have 1 on cos A. And what's 1 on cos A? Sec A. And where have I seen sec A before? On the left-hand side. QED. So I'm going to give you the proofs to do. So the proofs are in that booklet that I handed out. Now, those are two very common, what are they called? Operations that you might have to perform. Okay, so you have, where you have a couple of fractions, and you have to change the denominator of the fraction to combine them. That will come in very handy, as well as noticing those expansion patterns, difference of two squares. There might be a perfect square in there too. Okay. Anyway, I'm going to stop there and we're going to get to work.